So for my Calculus 1 class, let's take the same problem. I left this up there and I erased that other thing, and let's integrate it, okay? So we have a domain here, 0 to 8, okay? First of all, let's get some kind of an idea of what we're looking at. When you plug 0 into this quadratic, you get 0, okay? So it has a 0 here at the origin. And when you plug in 8, you get 88. We just did this, okay? So this thing looks like this. We have the line x equals 0, which is going to be our left boundary. So we can start setting up our integral, okay? Left boundary, x equals 0, right? 8 is the right side of our shape, yeah? So x equals 8. That's going to be our right boundary, vertical line, right? We have an upper function here, x squared plus 3x, x squared plus 3x, upper function minus our lower function, right? And then our lower function, since we want the area between this function and the x-axis, we know that this is the line y equals 0, right? So our lower function here is 0. We're going to chop this thing up into n rectangles, okay? And we're going to let this is going to be b minus a, so this would be 8 minus 0 over n, right? We're going to let n approach infinity, right? So as the limit of this thing, as n approaches infinity, this width of these itty bitty little rectangle is going to be dx. So this is going to give us the height of our rectangle, top function minus bottom function, height, and then we're going to have the width, which is dx. So height times width. This is going to be the area of one of the rectangles. And what this says is take the summation, the continuous summation, right? Notice how this summation looks kind of jerky, yeah? This is the discrete summation where you have a term here and another one and you add in these terms together, right? This is a kind of a flowing S, okay? It's kind of the same idea, but this is a continuous summation. We're going to get all the x's between 0 and 8. We're going to take the width of the rectangle, the height of the rectangle, we're going to add them all together, okay? Now, this shows explicitly what this integral is doing, okay? Upper function, lower function, the dx is measured on the x-axis, our left and our right boundaries. You would typically see this integral written like this. Okay? That's a typical notation, but just make sure that you understand what's going on here. So, we said that to do this, the first thing we need is we need the antiderivative. In other words, this is a derivative. Somebody took this derivative, okay? The question is, what did they take the derivative of? We know the rules for derivatives, so this is not going to be hard, right? So if they take the derivative and they get x squared, they must have started with x cubed, right? Because when you take the derivative of a function, what do you do with the exponent? You subtract 1. So when you get the antiderivative, you have to add 1, right? Now if I take the derivative of this, what do? I bring the 3 in front and I multiply this, and it turns into a 1. 3 times 1 is 1, so here we're going to have a third, right? 3 times a third is 1, there's our 1, subtract 1, that's what we get. Plus. Again, here we have x with a 1 exponent, right? So what did the original exponent have to be before they took the derivative? It had to be a square, yeah? So when we take the derivative of this, the 2 comes in front, multiply something to give you 3. That's going to be 3 over 2. Okay? So take the derivative of this, you'll get this. If you take the derivative of your answer, you don't get this, you got it wrong. Okay? So you don't ever have to turn it in wrong. I mean, just fix it. Make sure that you can take the derivative and get whatever is inside the integral. Okay? That's what we want. Now, if all we were after was the antiderivative, okay, we could add a constant out here, because when we take the derivative of a constant, we get 0, you know, and that would work, right? However, since we've got this definite integral, okay, this is an area, we can't just add arbitrary constants to definite integrals. So, we have this x equals 0 and x equals 8. So that's the evaluated from here to there symbol, right? We said that this means 2 parentheses with a minus sign in the middle. Take this function, copy it in here. Copy it perfectly. X cubed plus 3 halves x squared, okay? 1/3 x cubed plus 3 halves x squared. Okay, now I didn't put the x's. I said copy it perfectly, but you don't put the x's, okay? Because the first one here is going to get this top x, 8 and 8, right? And the second one here is going to get the bottom x. So you get 0 and 0. Notice that this is 0 from 0, this is 0, so this whole term is just 0, it goes away. So the answer to our problem here is going to be 1/3 of 8 cubed plus 3/2 of 8 squared. Okay? Now, this is going to be the area of the region under the curve. Do you have any questions about this? This is integration, okay? This is what we need to know how to do, folks. Send me an email, and I'll try to make another video to answer your questions.